right, hey guys, sorry about the bell. Today we're going to talk about absolute value equations. We talked about this today in my class, and what we found out was a lot of our kids don't quite have a lot of experience doing absolute value, let alone absolute value equations, which are going to be brand new. It's not something that's going to be completely impossible, but it is just going to take a little while to get the hang of it, especially if you're someone who's not that familiar with absolute value to begin with. So let me go ahead and give you the basics of absolute value first, and then we will move on to more advanced topics like absolute value equations. So if you weren't aware, right, absolute value is always represented by these bars. And you can have a number in there. It doesn't really matter. Sometimes it's a number, sometimes it's a letter, sometimes it can be negative, it can even be positive, it can be zero, right? Absolute value is always a distance, right? It is measuring the distance between a number and zero on the number line. So this is always a distance. And if you know anything about distance, think about it. Can distance ever be negative? It can't, right? I can't take a ruler out or a yardstick or a meter stick and ask you, hey, can you measure me -5 inches? It's not possible, right? So this will always be a positive measurement because these numbers are always a positive distance away from zero on the number line. Now, the number 6 is like 6 places to the right of zero. And then my last number down there, -3, is 3 places to the left, but there's still a positive absolute value because it is a distance. And it doesn't matter if you're to the right, to the left, up, down, whichever way, you're always going to be a positive distance. Distance cannot be negative. And so if you just have something like this, it doesn't matter if they give you a positive, it doesn't matter if they give you a negative. Any number that they give you will always be equal to a positive number because that is a distance away from zero. 6 places to the right, 5 places to the right, 3 places to the left. If you even want to write those words to the left at the beginning and to the right while you're getting the hang of it, that's fine. The only time these can never be negative is if they do something like this. Something like that, right? When the negative sign is outside of the absolute value bars. Now all of a sudden, we have absolute value of 3 with a negative sign on the outside. Now that is equal to -3. I could almost read that as the opposite of the absolute value of 3, right? Some people read it like that. They read a negative sign as the opposite of. And so if you're stuck on one that looks like this, when they start putting symbols on the outside, don't panic. What I kind of do is I treat an absolute value bar kind of like a parentheses that you have to do it first. And so in my head, I would solve this part first. Okay, what is the absolute value of 3? How many places away from zero is it? It's 3 places. And then I just kind of take this and attach it to my answer. So that is a quick reintroduction to absolute value in case you have never really been that exposed to absolute value, maybe only 1 or 2 days or not very much, or maybe it's just been a long time and you've forgotten about it. So it is always a distance. Now, they will start to give you some equations. They'll start out pretty easy. They may do something like this. Right? They might say something like this, right? Most of these will have 2 answers. Whenever you have a variable inside the absolute value bars that you need to solve for, most of the time they will have 2 answers. Now, it's not all the time, but most of the time, right? Think about this example. It's asking you what numbers have an absolute value of 2. That's basically, in other words, saying, tell me which numbers are 2 places away from zero on the number line, right? And so most people don't need to think too hard about it. Most people can say with pretty strong confidence that I know the number 2 and the number -2 are both 2 places away from zero, right? +2 is 2 places to the right. -2 is 2 places to the left. And so if I was going to solve this, I would say 2 and -2, you can write it like that. If you want to be really fancy pants, you can write it like this. Making you do plus and then a minus sign underneath it. Right? I think there is that button on the calculator on our Big Ideas Math website. if you ever wanted to use that button. So they're going to start out doing some pretty simple stuff like that, where it's just one variable inside the absolute value bars, and you just ask yourself, okay, what numbers are 2 places away from 0? Pretty easy. So we're off to a pretty good start. Now, you heard me say just a minute ago that most of the time we have 2 answers. Well, what are the exceptions to that, right? So the easy ones, right? This would be 6 and -6, right? This would be 1 and -1. It doesn't matter what letter or variable they use. They can use anything they want, right? That would be 80 and -80. Well, what about these, though? Switch these to a different color. Whoa, I don't look right. Let's fix that a little bit. What if they do one of these? Uh-oh. Now we got a problem, right? Absolute value, you heard me say at the beginning of this video, is a distance. Can you have any numbers that are -8 places away from 0? Impossible, right? Absolute value cannot be negative because it is always a distance. So if I see this equation in my book or in my homework or just wherever, this is impossible. This has no solution. Remember how we talked about that the other day? You can write it like that. You can do this thing, right? There is no answer to that. So I don't have 2 answers. I have no answer. There is no answer. It is impossible to pick a number on the number line and then have that number be -8 places away from 0. It's not going to happen, right? Distance cannot be negative. So this has no solution. This would have no solution, right? That would have no solution. If it's negative anything and you just have a plain old absolute value on the left, you know it's going to be no solution. So that doesn't have any answer. Most of the time you have 2 answers. Every once in a while you can get 1 answer. And the only exception, the only time you can get 1 answer is if you have this. Right? How far is the number 0 away from 0? That's kind of a weird question, right? It is the number 0. So that is the only time where you will have 1 answer. There is no such thing as +0 and -0. So that's only going to have 1 answer. So if it's 0, you'll have 1 answer. If it's a positive number, you'll have 2 answers. And if it's a negative number, you're not going to have any answer, right? No solution. There is no answer to that one. So that's kind of the way you can keep it straight whenever they have a very, very simple equation. All these equations are extremely simple. What I mean by simple is if you look at the left-hand side, inside the absolute value bars, we really didn't have anything except for just a plain variable. You know what I mean? Here's eventually what's going to happen. They're eventually going to give you questions like this. So now this is where it starts to pick up a little bit, right? In the assignment today, I want to say number 14 or 15 is where it starts to look like this. We have an absolute value bar that has a bunch of stuff in it, right? We got an X, which was what we are used to seeing, but now we've got addition with the number 6. We've got multiplying with the number 5. We got a whole bunch of stuff there. Don't let that throw you off. We're still going to do kind of the same thing, right? This whole thing, whatever it equals, it has to be 31 places away from 0. It has to be 31 places away from 0. So remember from the very beginning, how many numbers are 31 places away from 0? How many answers could we have to this? We should have 2 answers to this, right? Anytime you have the absolute value isolated over here, there's no extra stuff. We'll talk about that in a minute. But there are 2 possible answers to this, right? If all this stuff equals 31, we would have an absolute value that would equal 31. Or all this stuff in here could equal -31, because isn't -31 also has an absolute value of 31, right? So we need to solve this for both equations. Now, I haven't solved it yet. I'm just showing you, right? The stuff on the inside, this stuff right here, it could equal either one. There are 2 possible totals that the 5x plus 6 could equal. It could equal 31, or it could equal negative 31. Because no matter what you get in here, whenever you do absolute value, it's always going to switch to positive. So here is the process. And I think I might have over-explained that, and maybe I confused you too much. Okay, big idea for today. First, double check on the left-hand side, whichever side the absolute value is on. Ask yourself, is the absolute value bars, is that the only thing on that side of the equal sign? And the answer is yes. You know, there's no like adding or subtracting or multiplying or any other junk that's outside of the bars. If the bars are the only thing over there, you are ready to proceed. And now here's how you do it. You take the problem, and you need to solve this 2 times. And the reason we solve it 2 times is because there are 2 numbers that are 31 places away from 0 on a number line, right? And so we're going to solve this problem twice. The first time we solve it, I'm just going to copy this down, right? Notice, whatever was inside the absolute value, I just copied it down. I don't have the bars anymore. I'm going to solve this once for 31, because the absolute value of 31 equals 31. And then I'm also going to take the same equation on the left-hand side, 5x plus 6, right? I'm just going to take this. And now I need to figure out negative 31. Because if this equaled negative 31, it would still have an absolute value of positive 31. So, big idea today. First, you want to check, make sure the absolute value bars are isolated. That means they're the only thing on that side of the equal sign. If they are the only thing on that side of the equal sign, then you split it into 2 problems. One time you do positive, whatever number this is. One time you do negative, whatever number this is. And then everything else from here is super easy, right? This is just a 2-step equation. Everyone in the room or at home should know how to do this, right? We're going to undo the adding with subtracting. We're going to undo the multiplying, because this is technically multiplied. We're going to undo the multiplying with division. And there's one answer, x equals 5. And then you get another answer over here, same idea, still subtract 6 on both sides. Oops, I erased it, that should be negative 31. Switch back to red. Negative 31 minus 6. Oh, geez, sorry guys, I made a bad question here. I just made this up off the top of my head. And then divided by 5. Okay, I apologize for the decimal on this one, but that's the way it goes sometimes when you make questions up in your head, right? And so I should have 2 answers. Now, I have one positive answer and one negative answer. Will it always be that way? No. A lot of the times it is, but if you wanted to double check this, you could take the answers we got, take 5, plug it back into the original problem, and if you work it out, 5 times 5 plus 6, does that equal 31? Yes, and so I got that one right. And then I could take my other one, which I kind of goofed up on, and if you don't believe me, let's see if I can do this. Take my calculator, and if I take my answer of negative 7.4 and plug it in right here, right? I take my answer and drop it in right there, and I check it to see if I'm right. I could do 5 times 7.4 negative, and then I can add 6 to it. Whoops, not 66. You'll see right here, I got negative 31, and negative 31 would have an absolute value of 31. So I did that one right. So that's the big idea today. Double check, make sure that it's isolated all by itself, and then you can split it into 2 problems, positive and negative. Whatever the number is at the end, ours had 31, and then you can just work it out. Let's do another one. Well, you know what? Let me grab the book. I'll grab the actual book so I don't do one that has a crazy decimal in it. That was kind of weird, wasn't it? So let's look at a different one. We'll do one more like this. Okay. We're going to do a different one. How about this one? Okay. So I'm going to do a quick double check. It's pretty obvious that 4 is probably going to work on this one, right? Because 4 plus 3 equals 7. But I'm going to take this and I'm going to check. Is this isolated all by itself? Yes. So now I can split it. I'm going to take this statement and I'm going to write it twice. Once over here. Once over here. And one time I'm going to make it equal positive 7. And the other time I'm going to make it equal negative, whatever this is, in this case 7. And then you can just work out each one. Subtract 3 on both sides. And you get n equals 4. On this one, you subtract 3 on both sides. You get n equals negative 10. And so you see on this one, we got one negative and one positive number again. Don't think that's always going to happen. It won't always be that way. And so if you put 4 up there, 4 plus 3, yep, that equals 7. If I put negative 10 right here, would that be a true statement? Yeah, that's a true statement because negative 10 plus 3 is negative 7. And the absolute value of negative 7 is 7. Okay, when they are rude, here's what they'll do. And then we'll do one last one. When they are rude, they will give you one like this. Uh-oh. Now we got a problem. The absolute value bars are isolated on the left-hand side. However, can absolute value ever be a negative? No. And so if this is isolated over here, it's the only thing over there. There's no other extra junk outside the bars, and it equals a negative, well, this is one you know is going to be no solution. There's no answer to that one. Okay? Now, the hardest ones they can give you. Here is maybe the hardest one that we could possibly get today. Let me see how I want to make this one look. Oh, geez, Louise. Let's do this one. Let's do this guy. Yeah, look at this nonsense, right? We got this whole thing up there. Remember what I said at the very beginning of the question? You need to check to see if the absolute values are isolated. Is this absolute value bar the only thing on the left-hand side of the equation? No way, Jose. It's not even close. So what does that mean? It means before I decide if this is one that we can answer or one that we can't answer, we need to get the absolute values isolated on the left-hand side, or whichever side they're on, right? Get it so that the absolute value bar is the only thing on the left-hand side of the problem. So we want to do inverse operations. Instead of plus 8, we want to do minus 8. And we're doing all this before. Notice, I haven't split this problem up yet. There is no splitting it into positive and negative until you get the bars isolated on the left-hand side. So now I have this. And this is really a way to show multiplying, right? That's 9 times whatever the absolute value is. So I want to undo multiplying with dividing. So I'm going to divide by 9 here. I'm going to divide by 9 here. And that leaves me with this. The absolute value of 4p plus 2 equals 3. Now, do you see the difference compared to what it looks like now, compared to where it started? Let me get the glare. It's right in the glare. I apologize about that. I have the absolute value bars as the only thing on the left-hand side of the problem. Now is the time when it is appropriate to check, okay, is this one that's going to have 2 answers? Is this one that's going to only have 1 answer? Is this one that's impossible where I would put no solution? Right? And this is a normal one. Let me move that out of the glare. Well, I guess I really can't. I apologize again. So this is a normal one. Every once in a while, they'll be really rude to you. They'll give you a crazy looking one and they'll put a negative out here and they'll ask you if it's possible. And they want you to fall in the trap of just looking and saying, oh, if it equals a negative, it's always, 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 always impossible. And it's always going to be no solution. No, you've got to get the absolute value bars isolated. Once you get them isolated as the only thing on that side of the equal sign, then you can check and you can see if it's the only thing over there on the left-hand side, Then if you've got a negative, then you can say it's no solution or it's impossible. But right now, we can solve this one, right? We can solve this one just like the last one. I have the left-hand side. The absolute value bar is completely isolated on the left-hand side. So that means I'm ready to split it. I'm going to do 4p plus 2 over here. I'm going to do 4p plus 2 over here. One time, I'm going to make it equal positive 3. Let's do that one right here. The other time, I'm going to make it equal negative 3. And so from here, you just get to solve it like normal. Ooh, this one's kind of icky. We're going to end up with a fraction right here, aren't we? 4 times something equals 1. 1 divided by 4. I'm out of space, but that's going to be 1/4. And then over here, same idea. Subtract 2 on both sides. 4 times something equals 5. Boy. So then divide by 4, and you get this. Negative 5 over 4, which is negative 1.25. I wish I had more room, but I'm out. So that is about as hard as it gets. Give that one a look. If you need to rewind it and do what you need to do. Real quickly, here are my big steps, right? Step 1, what should you do first on all of these? Isolate the variable. No. The absolute value. I'm so used to saying that. Isolate the absolute value bars, right? And then number 2, once you get it isolated so that the absolute value is the only thing on that side of the equation, then you can check to see how many solutions, right? If it's equaling a positive number, you'll have 2 answers. If it equals 0, you'll only have 1 answer. If it equals a negative number, once you get it isolated, you aren't going to have any solution and you can stop. And then here's finally, you're going to split it. You're going to split it into 2 equations, right? 1 positive and 1 negative. 1 positive and 1 negative. And then finally, you're just going to solve both of them. And step 4 is usually the easiest step. If you can get to step 4, you're in great shape. And even step 3. So I'm almost at 22 minutes. You know what? Let me do one last one because I feel like people are going to get a little bit antsy and they may not quite understand yet. I'll do one final one and then we will be ready to go. If you think you've got it and you want to quit watching the video right now, you go right ahead. Okay, this is one that is a great one. Okay, step 1. Notice my step 1 is isolate the absolute value bars. My step 1 right now, don't you dare think, oh, since this is negative, I can't do it. No. You're too early on that. Before you can decide if you can solve it or not, you have to isolate the absolute value bars. So what extra stuff do we have? The absolute value bars are fine, but we have this extra stuff out here. This is outside of the bars. This is not supposed to be there. So I need to undo -9 with +9. And once you do that, you get 4. And now take a look at it. Now I can decide, can I answer this one? Because look, this is isolated. It's the only thing on the left-hand side is the bars. There's no more extra junk hanging out up there, right? So this is okay. I can answer this because it's a positive number. That tells me I'm going to have 2 answers on this. So I've isolated it. Check to see how many answers. I know I'm going to have 2 on this one. Now I'm going to split it into 2 equations. Let me split this. Here's one. Here's the other. One of them's going to equal positive. One of them's going to equal negative. And here's my number, right? Positive 4 and negative 4. One's going to be 4. One's going to be negative 4. And then step 4, I'm ready to just solve it. And this one is going to have another decimal. Oh, geez. This one is going to be -4 divided by 3, which is what? -1 1/3. I'm not going to write it, but that's what it is. And look at this guy. -4 minus 8 is -12. And this one you get, whoa, -12 divided by 3 which is -4. So you see on that one, we have 2 negatives. So it doesn't have to always be one positive, one negative. Okay, I'm at 25 minutes. I apologize for the length of this one. Please use this to go back and check if you're trying to work some of these out and you're having a hard time. You can go step by step, pause my video, rewind it, go forward, backwards, whatever you need. We will have some questions. In fact, I think I already have them on there on Big Ideas Math. They're called absolute value equations, maybe 1.4. You can give them a try. Some of the questions that I tried in this might actually be very similar to the ones in the assignment. So go ahead and give those a shot tomorrow on Wednesday. Or that was the assignment for today. And you can give them a try tomorrow on Wednesday, and we will see how you do. Feel free to email me or send me a message in Google Classroom if you're having a hard time or you want me to explain it anymore. All right. Thank you so much, guys. Have a good one.